Welcome to Basic Foundation Maths Lecture 4. Today's topic is quadratic equation, so let's get into it. In the last lecture, we dealt with linear equations in one variable and two variables. So if you recall, linear equation in one variable is of the form ax plus b equals 0, where x is the variable. Now if you notice, the power of x here is 1. Now quadratic equation is of the form ax square plus bx plus c equals 0. Here note that the maximum power of x in this is 2, where in linear equation it is 1. Examples of quadratic equation are 2x square minus 5x plus 6 equals to 0. This is an example of quadratic equation where a in this case is 2, b is minus 5, c is 6. X square minus 16 equals to 0 is also a quadratic where a is 1, b is 0 because there is no x term, and c equals minus 16. 3x square plus 7 equals to 0 is also a quadratic equation. Now next is roots of a quadratic equation. So let's say someone asks you to solve x square minus 16 equals to 0. So the method to solve this is, we'll write x square equals 16. So x equals square root 16, which is plus minus 4, which means x is either plus 4 or x equals minus 4. So we can write roots of x square minus 16 equals 0 are x equals plus 4 comma minus 4. So these are the roots of this quadratic equation. What it means is this value of x would satisfy this equation. Let's do few questions. Question: solve x square minus 12 equals 0. So to solve this, we will take 12 on the other side. So we can write x will be equals to plus minus under root 12. So this will be equals to plus minus. Now 12 we can write as 4 multiplied by 3. So that will become 2 root 3. So roots of x square minus 12 is plus 2 root 3 or minus 2 root 3. Another question: 25 x square minus 144 equals 0. So we can write 25x square equals 144. So x square equals 144 by 25. So this implies x equals 12 by 5, and that is plus minus. So this is the solution or the roots of this equation. Now next is methods to solve quadratic equation. There are three methods that we use to solve quadratic equation. So let's see them one after another. So first is factorization method. There are three steps to apply factorization method. So let's have a look. So first step is we write given quadratic equation in the form ax square plus bx plus c equals 0. We also identify values of a, b and c. Second step is we split b into two parts, b1, b2, such that b1 plus b2 equals b and b1 multiplied by b2 equals ac. This b1 and b2 are obtained by hit and trial and following these constraints, ensuring these two equations are true. Students would require a lot of practice to be able to do the split. Third step is we split middle term into b1x and b2x. That is ax square plus bx plus c equals to 0. We write it as ax square plus b1x plus b2x plus c equals to 0. Now we factorize the equation and proceed. Let's understand this by an example. Even before taking an example, let's see one more thing. If product of two numbers equal 0, it implies either one of them is 0. Meaning, if x multiplied by y equals 0, so this implies either x equals 0 or y equals 0. Similarly, if x plus 7 multiplied by x minus 1 equals 0, so this implies either x plus 7 equals 0 or x minus 1 equals 0, that is x equals minus 7 or x equals 1, that is x equals minus 7 or 1. We can also see that when you substitute x as 1, we get this as 0, so overall equation becomes 0, so it satisfies. Similarly, x equals minus 7 will also make this 0, and hence the overall equation will become 0. Now let's understand this factorization method by an example. Now this is a quadratic equation, so let's do it step by step. So step 1 is we identify a, b and c. So here a equals 1, b equals 5 and c equals 6. Now step 2 is we split b into two parts, b1 and b2, such that b1 plus b2 equals b, which is 5, and b1 b2 equals ac, which is 6. So by observation we can see that b1 and b2 can be 2 and 3. We can also take 3 and 2. Both will work just fine. Now that we have the values of b1 and b2, we can split the middle term of the quadratic and then factorize. We group these four terms like this, so we get x multiplied by x plus 2, and in the second bracket we can take 3 common, so we get x plus 2 as common, and this equals 0. Now if you realize, we have x plus 2 here also and here also, so we can take x plus 2 overall common. So the moment we do this, we will get x plus 3 equals 0. If their product is 0, it means either x plus 2 equals 0, which is x equals to minus 2, or x plus 3 equals 0, which is x equals minus 3. So therefore roots are x equals minus 2 comma minus 3. So these are the roots of the given quadratic. Now we can see that if we substitute x equals to minus 2 in this equation, it will satisfy. That is, this will become 0. Same thing for x equals to minus 3. Let's see a few more examples. X square plus 5x minus 6 equals 0. Now we'll try and do things a little bit directly. So here we can see a equals 1, b equals 5 and c equals minus 6. So we need to split b into two parts such that their addition is 5 and their multiplication is AC. So AC in this case is minus 6. So we can just guess the number. This will be plus 6 and this will be minus 1. We can see that their addition is 5 and then product is minus 6. So x square plus 6x minus x minus 6 equals 0. Now we can group these two together and these two. So here we can take x common, we'll get x plus 6. Here we can take minus 1 common, we will get x plus 6. So overall we can take x plus 6 common. We'll get x plus 6 multiplied by x minus 1 equals to 0. So this implies either x plus 6 equals 0, that is x equals minus 6, or x minus 1 equals 0, which is x equals to 1. Therefore, roots are x equals minus 6, 1. Let's see one more example. 6x square plus x minus 2 equals 0. So here a equals 6, b equals 1, and c equals minus 2. So we need to split this into two parts such that their addition is 1 and their product is AC, which is equals to minus 12. So by hit and trial, we can see that this will be plus 4 and minus 3. Their addition is 1, their product is minus 12. Now we'll split the middle term here. Now in the first pair, we can take 2x common. We'll get 3x plus 2. In this, we can take minus 1 common. We'll get 3x plus 2 equals 0. Now we can take 3x plus 2 common. We will get 2x minus 1 equals 0. So this implies either 3x plus 2 equals 0, or x equals minus 3 by 2, or 2x minus 1 equals 0, that is x equals half. So roots of the given equation are x equals minus 3 by 2 comma half. So if you want, you can check both these values will satisfy the given equation. We just saw the first method, which is factorization method, to solve quadratic equation. Now let's see the second method, which is called the formula method. Now in this method, we solve the given quadratic equation by using a formula, which is x equals minus b plus minus under root b square minus 4ac whole divided by 2a. So this formula we need to memorize, and we can use this formula to get the roots of the given quadratic equation. Now let's do the same question that we just did using the formula. So first example was x square plus 5x plus 6 equals 0. So first we need to identify a, b and c. So a equals 1, b equals 5, c equals 6. Now we can just use the formula. So x equals minus, so b is 5 plus minus square root of b square minus 4 multiplied by a multiplied by c whole divided by 2 times a, that is 2 times 1. So this will be minus 5 plus minus square root 25 minus 24 whole divided by 2. So we will get x equals minus 5 plus minus. So this is 1. Root 1 we will get 1 whole divided by 2. Now this plus minus means that once we take x equals minus 5 plus 1 by 2, and in second case we take minus 5 minus 1 by 2. So we get x as minus 4 by 2, that is minus 2 comma minus 3, which are the same roots that we got earlier. Formula method primarily helps when it is difficult to factorize a given equation. So let's see an example. X square minus 3x plus 1 equals 0. Now here you will find it is very difficult to split the middle term in such a way that their addition is minus 3, the product equals AC. So here the factorization method will be very difficult to use. So we'll try and use the formula method here. So first we will identify A, B and C. Now we'll use the formula. So x equals minus b plus minus square root b square minus 4ac whole divided by 2a. Minus of minus 3 plus minus square root b square minus 4ac whole divided by 2a. So this equals plus 3 plus minus square root 9 minus 4 whole divided by 2. So this equals 3 plus minus root 5 whole divided by 2. So the roots are x equals 3 plus root 5 by 2 or 3 minus root 5 by 2. Now one more thing that we can realize here is that if the number inside the root is not a perfect square, you will end up getting two roots which are conjugate of each other. That is, if b square minus 4ac, which is a term inside the root, is not a perfect square, then the roots are irrational because these have roots in them and they form conjugate pair. Conjugate pairs. Three plus root 5 and 3 minus root 5. These are conjugates of each other. Similarly, if we notice that b square minus 4ac in this case is 1, which is a perfect square, so finally we have rational roots. So roots are rational. So let's see one more example. 9x square minus 12x plus 4 equals 0. So here a equals 9, b equals minus 12 and c equals 4. So let's find the roots using the formula. So x equals minus b plus minus square root b square minus 4ac divided by 2a. So this equals minus 12 plus minus square root. This will be minus 12 square minus 4 multiplied by a multiplied by c whole divided by 2a. That's 2 into 9. So this equals 12 plus minus square root 144 minus. This will also give us 144 whole divided by 18. So we will get 12 plus minus square root 0 divided by 18. So this equals 12 plus 0 by 18 and 12 minus 0 by 18. So x equals 12 by 18 or 12 by 18. So if we see, we have got two roots, but in this case they happen to be equal, which we can simplify and write 2 by 3 comma 2 by 3. Now here roots are real and equal. So if we notice, the reason why the roots came out to be equal is because b square minus 4ac here becomes 0. So in general, if b square minus 4ac becomes 0, so we get roots which are real and equal. We'll also see later on that b square minus 4ac is coined the term discriminant because this becomes important in deciding the nature of the roots. Let's see the third method of finding the roots of a quadratic equation. This is called completing the square method. So let's understand this by an example. X square plus 3x plus 1 equals 0. So the rule is we add and subtract half the coefficient of x whole square in LHS. So if we realize here the coefficient of x is 3, so we add and subtract 3 by 2 whole square in the LHS. So the equation will become x square plus 3x plus 1. We add and subtract half the coefficient of x square, which is 3 by 2 square, and minus 3 by 2 square equals 0. Now this whole thing is a perfect square, so this we can write as x plus 3 by 2 the whole square plus 1 minus this will be 9 by 4 equals 0. So this implies x plus 3 by 2 the whole square equals this upon simplification will give 5 by 4. So x plus 3 by 2, if we take the root on the right side, we will get plus minus root 5 by 2. So this implies x equals minus 3 by 2 plus minus root 5 by 2. So the final answer is minus 3 plus minus root 5 by 2. So the roots are x equals minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. So here we tried to convert x square plus 3x into a perfect square to be able to solve by this method. So this is called completing the square method. Now next is discriminant. So we have already seen the formula used to find the roots of a quadratic equation. We have also seen that this value b square minus 4ac helps in deciding whether the roots would be equal, unequal, real, imaginary, etc. So essentially, the value of b square minus 4ac becomes important to us in the sense it will help us decide whether the roots will be real, imaginary, equal, unequal, rational or irrational. So we give it a new name, discriminant, which is denoted by d, and it is equals to b square minus 4ac, where d is the discriminant. Using the discriminant, we can find the nature of roots of ax square plus bx plus c equals 0. So let's see how. So first we find discriminant, which is b square minus 4ac. Now we will have three scenarios. Either the discriminant will be less than 0, or the discriminant will be greater than 0, or the discriminant will be equals to 0. So if the discriminant is less than 0, we know by formula x equals minus b plus minus square root b square minus 4ac, which in this case will be capital D divided by 2a. So if discriminant is negative, we can see that root of negative numbers does not exist. So the roots will be imaginary. That is, roots will not be real. Next, if d equals 0, then the roots will be real and equal, because if d becomes 0, x will be equals to minus b plus minus square root 0 divided by 2a. So whether I do plus 0 or minus 0, both will give me the same root, which is minus b by 2a, comma, minus b by 2a. One more important note is, if d becomes equals to 0, then the expression ax square plus bx plus c forms a perfect square. We will see this by an example. Now the third is, if the discriminant is greater than 0, then the roots will be real and distinct. In this category, the roots are equal. In this, roots are not equal, that is, distinct. Further, if a, b and c belongs to rational number and d is a perfect square, then the roots will be real, distinct, as well as rational. This is because if D is a perfect square, then square root of a perfect square will give us a rational number. And since ABC are rational, so overall the roots will be a rational number. If D is not a perfect square, then roots will be real, distinct, and irrational. This is because if D is not a perfect square, the square root will not completely go away. So we'll be left with a surd which will be irrational. Not only this, the roots will occur as conjugate pairs. That is, if one root is p plus root q, then other root will be p minus root q. Now let's do few problems. So let's say we are supposed to find the value of p for which this equation has real and equal roots. So for real and equal roots, we saw that the discriminant of this quadratic equation must be 0. So let's identify A, B and C. So A is 4, B is P and C is 9. Now the discriminant D equals B square minus 4AC, which equals to P square minus 4 multiplied by 4 and 9. So this equals P square minus 144. Now for real and equal roots, D must be 0. So for D to be 0, P square minus 144 equals 0. So this implies P square equals 144. So this implies P equals plus minus 12. So that means when P equals plus 12 or P equals minus 12, we get real and equal roots for this. Now this exact same question can be asked in a different way. Find the value of P for which the following expression is a perfect square. So if you refer the tree diagram, you will see for an expression to be a perfect square, the discriminant of that quadratic expression must be 0. So if you want to solve this question, we will follow the same steps and we will make discriminant as 0. So that implies we will again get P as plus minus 12. Now just to explain this, let's take a value of P as minus 12. Now 4x square minus 12x plus 9 equals 0. So to solve this, we will split this into two parts, which will be minus 6x minus 6x plus 9 equals 0. So we can take 2x common. We will get 2x minus 3 and then minus 3 common. So we can take 2x minus 3 whole common. We'll get 2x minus 3 equals 0. So if you realize, this expression just became a perfect square. And if you want to find the roots, we will get equal roots, and both roots being equal plus 3 by 2. Now let's move on. Now next is sum and product of roots of ax square plus bx plus c equals 0. Now if you recall,
The roots of these equations were minus b plus minus root b square minus 4ac divided by 2a. So once we can take plus to get one of the roots, and then we can take minus to get the other root. So these are the two roots of this equation. Now let's call these roots as alpha, which is a Greek letter, and this as beta, which is another Greek letter. So sum of roots equals alpha plus beta equals minus b plus root b square minus 4ac divided by 2a plus minus b minus root b square minus 4ac divided by 2a. Now if you take LCM, it will be 2a, and this whole expression will get cancelled. So finally we will get minus b by 2a, so that equals minus 2b by 2a, so that equals minus b by a. Now similarly, if you find the product of roots, we will get alpha multiplied by beta as minus b plus root b square minus 4ac divided by 2a multiplied by minus b minus root b square minus 4ac divided by 2a. So when you simplify this, you will end up getting c by a. So we need to memorize these end results, that sum of root is minus b by 2a and product of roots is c by a. So let's summarize. So the sum and product of roots of ax square plus bx plus c equals 0 is alpha plus beta equals minus b by a, product of roots alpha beta c by a. So we need to memorize both of these formulas. Now next is quadratic equation whose roots are alpha and beta is x minus alpha multiplied by beta equals 0. So example, let's find a quadratic equation whose roots are 2 and 3. So the equation will be x minus 2 multiplied by x minus 3 equals 0. So this implies x square minus 2x minus 3x plus 6 equals 0. So this implies x square minus 5x plus 6 equals 0, which is the required quadratic equation. Now if you solve this quadratic equation, you will see that 2 and 3 are actually the roots of this equation. Now let's do a few questions. So if one root of 6x square minus 13x plus k equals 0 is reciprocal of other, then find k. So we need to find the value of k such that the roots are reciprocal of each other. So since k is unknown, we cannot actually find the roots of this equation. So we'll assume let the roots of the equation be alpha and beta. Now you realize instead of beta we can write 1 by alpha because the roots are reciprocal of each other. So if one root is alpha, the other has to be 1 by alpha. Now next we know sum of roots equals alpha plus 1 by alpha equals minus b by a. So if you realize a equals 6, b equals minus 13, c equals k. So this will be equals to minus of minus 13 by 6. So this is one equation we will get. Now let's write the other equation as well. So product of roots equals alpha multiplied by 1 by alpha equals c by a. If you realize alpha multiplied by 1 by alpha, alpha will get cancelled, we get 1. C is k, a is 6. So finally we will get k as 6. So when k is 6, the answer to this, the roots of this equation will be reciprocal of each other. So essentially, try solving 6x squared minus 13x plus 6 equals to 0. You will see that the roots will be reciprocal of each other. Now let's do one more question. If one of the roots of a quadratic equation is 1 plus root 3, then find the quadratic equation. Now here we'll use that property. Now here, if you recall, in the tree diagram we have seen that irrational roots always occur as conjugate pairs. So if one root is other root has to be 1 minus root 3, because these two form conjugate pairs. Now this is alpha and this is beta. So quadratic equation will be x minus alpha multiplied by x minus beta equals 0. That is x minus 1 minus root 3, x minus 1 plus root 3 equals 0. So we can multiply and get the answer. So the final answer will be x squared minus 2x minus 2 equals 0.